Isochoric process, a process in which volume of the system remain constant is known as isochoric process. Since volume is constant, so change in all volume will be equal to 0. And we know that the work done is W is equal to minus P dV. Since dV is 0, so it means that the work done will be equal to 0. And the first law of thermodynamics is change in internal energy will be equal to the heat supplied to the system plus work done. Since dW is 0, so it means that change in internal energy will be equal to dQ. Now this implies that the heat energy is supplied to the system. If there is no work done, then it will totally increase the change in internal energy. In other words, all heat is supplied in such a way that it can increase only the internal energy of the system. Because work done is 0, so change in internal energy is equal to the heat supplied. So the heat supplied to the system will only increase the internal energy while the work done is 0. Next we have isobaric process. Isobaric process, a process in which pressure remains constant, is called isobaric process. A process in which pressure remains constant is known as isobaric process. Now since pressure is constant, P is constant, this implies the change in pressure dP will be equal to 0. Now the first law of thermodynamics is change in internal energy will be equal to the heat supplied to the system plus work done. So in case of constant pressure, the work done is, since pressure will remain constant, so it means that volume is changing. So the volume will change from initial volume to final volume, which is minus P dV. Since pressure is constant, so dW is equal to minus P dV. Now if we integrate this equation, dW is equal to minus integral of P dV. Pressure is constant, so volume is changing, which is changing from initial volume to final volume. So on this side we have work, if we integrate it, and on this side we have minus P is a constant which can be bring outside of the integral, and we have VI to VF dV. Now if we integrate this, then the work done will be equal to minus P into V, and the limit is Vi to Vf. So the work done will be equal to minus P Vf minus Vi. This is the work done in isobaric process. This is work done in isobaric process. Now next we have isothermal process. A process in which the temperature of the system remain conserved or remain constant. The process in which temperature of the system remain constant is known as isothermal process. Since temperature is constant, so change in temperature will be equal to 0. Now internal energy, the E internal, is a function of temperature. If temperature doesn't change, then internal energy, if temperature is constant, then internal energy will also remain constant, because internal energy is a function of temperature. It will remain constant. So this implies that the change in internal energy, dE internal, will be equal to 0 also, because temperature and internal energy are related to each other. There is a relation, direct relation. Now if internal energy is 0, then we have the first law of thermodynamics, which is dE internal is equal to change in internal energy is equal to the heat supplied plus the work done. Now this is 0, so we have Q plus W. The heat supplied to the system will only do work on the system. Like the heat supply, before this, the heat supplied to the system will increase the internal energy by dE internal and do some work if we supply heat to a system. But in this case, internal energy is 0, change in internal energy is 0, so the heat supplied to the system will do only work on the system. Now we have to calculate the work done. The work done is W is equal to minus integral from initial volume to final volume, and we have P dV. Now we have only temperature is constant, so pressure and volume are both variable quantities. So we know that PV is equal to N or T. P is equal to N or T over V. Using the value of P in this equation, we get the work done is equal to minus integral from initial volume to final volume, and we have N or T over V into dV. Now this N or T is constant, so we can bring it outside of the integral. So the work done is minus N or T, because temperature is constant, R is constant, N is constant. So we have integral from initial volume to final volume dV over V. From this integral we get minus nRT ln V, log of V, and we have the limits from Vi to Vf. We get minus nRT, and here we have ln Vf minus ln Vi. And we know that natural log of A minus natural log of B will be equal to natural log of A over B. So from this we get minus nRT, and we have ln Vf over Vi. And this is the work done in isothermal process. This is the work done in isothermal process. And the final top application is cyclic process. I think no, there is also the free expansion and two more application of first law of thermodynamics, which we will discuss in the next video. Thank you.